Okay, this is getting close to some of our final videos here. And today it's about probability of compound events. So our compound events, we've already talked about what compound events are, but finding the probabilities, we can now use our combinations and permutations to actually help us determine our sample space, our number of outcomes. So our first example, it says using an organized list to find probability. I'm going to show you that, but I think it's easier actually to do a tree diagram. So a pizza parlor offers 7 different pizza toppings: pineapple, mushroom, Canadian bacon, onions, pepperoni, beef, and sausage. What is the probability that a random order for a 2-topping pizza includes pepperoni? And then second one, what is the probability that a random order for a 2-topping pizza includes onion and sausage? So they do a list right off the bat, and when they do their list, let's see if I can get that out of the way there, they let P be pineapple, M mushroom, C Canadian bacon, O for onions, PE for pepperoni, B for beef, S for sausage. And the order of toppings does not matter, so you can eliminate repeated pairs, which also means since order doesn't matter, you could use a combination to find out how many pairs there are. So let's see. Here's their organized list. And what they do here is they cross out any repeats. So here's pineapple, mushroom, mushroom, pineapple. And then Canadian bacon and pineapple, and Canadian bacon, mushroom. So anything crossed out are repeaters. So really there's no sausages as sausage first at all, but order, remember, doesn't matter. So when we look at this, we could count them all. And if you count them all, you would see that there's 1, 2, 3, 4, 5, 6. So there's 5 there, so that's 11. 4 here, so that's 15. 3 here, so that's 18. 2, 20, and 1, 21. So there's 21. And then they highlight the things we need. We need anything with pepperoni in it. 1, 2, 3, 4, 5, 6. So that'd be 6 out of 21. And that would be a way that you could do it. So 6 out of 21, and you could reduce that to 2/7. Then for B, to have onion and sausage, well, there's only one way you can have onion and sausage, because onion, sausage, sausage, onion isn't included because it doesn't matter what order. So that would just be 1 out of 21. Now, I'm going to show you using my paper how I would do it, because I think it's a lot faster, and hopefully you can see this, and I will try hard not to shake it. But what I did was start out with pineapple and do all the other toppings that could go with pineapple. Of course, you cannot have pineapple. So there is 6 possibilities. Then mushroom, you would have 5 because you don't need the mushroom with the pepperoni. I'm sorry, with the pineapple, you can eliminate pineapple. So then with Canadian bacon, there will be 4 because you can eliminate the mushroom and Canadian bacon and the pineapple and Canadian bacon. So there would be your 4 possibilities. And then onion, just kind of the same pattern all the way down the line. And so you can see, if you count all the branches, there are 21 possibilities. And I apologize, my light just went off. Let me turn this light on. See if that helps. Yes, okay. And then to check 21 possibilities, I just did a combination of 7 things taken 2 at a time, since order is not important. So that gives me 7 factorial over the 2 factorial, and then times a quantity 7 minus 2 factorial. So my 7 factorial, I have 7 times 6 times 5, 4, 3, 2, 1. I'm just going to do the 5 factorial, and that's my phone going off. That's my husband. I'll answer it later. So the 5 factorials would cancel, and then my 2 factorials, just 2 times 1. Well, I could cancel the 2 with the 6 or divide out a common factor of 2, and I'd have 3 left over. So that leaves me with 7 times 3 over 1, or 21 possibilities. Now, the probability of random order includes pepperoni. Well, what I did in red is I just went up and found all the types with pepperoni. So you have pineapple pepperoni, mushroom pepperoni, Canadian bacon pepperoni, onion pepperoni, bacon, or I'm sorry, B. I forget what B is. Beef and pepperoni, or sausage, sausage and pepperoni, which is my husband's favorite. And there he is, and I'm going to tell him I'm going to call him back. Oops. Let me call you. Oh, okay, he's not there anymore. Here I am. Let's see if it's still working. Okay, sorry about that. So then, that gives me 6, so 6 out of 21, and that's the same as doing the list, but I just think this is faster. And then random order probability that it has onion and sausage. Well, there's only one onion and sausage, and I highlighted that. So I think that's a lot easier to do that problem. All right, so the next problem, we have Kate, Jack, and Jack, Kate, and Linda line up in random order in the cafeteria. What is the probability that Kate randomly lines up between Jack and Linda? What's the probability that Kate randomly lines up last? So I would do a tree diagram there as well. And we do that, and notice they say permutations because order is important. So we could have Jack and Kate and then Linda, or Jack, Linda, and then Kate. We could have Kate, Jack, Linda, or Kate, Linda, Jack. Or we could have Linda, Jack, Kate, Linda, Kate, Jack. So there are 6 possibilities. You could also do this with a permutation. And just real quick to show you that, that would be total possible outcomes, or the permutation 3 things taken 3 at a time. So that's 3 factorial over 3 minus 3 factorial. So that's 3 times 2 times 1 over 0 factorial, which is 6 over 1, which is 6. So there's 6 ways to order, which we see in this tree diagram as well. So then it says, what's the probability that Kate randomly lines up between Jack and Linda? And you can see here's Kate between Jack and Linda, and here's Kate between Jack and Linda. So that would be 2 out of 3, or reduces to 1/3. And then the second one, probability that Kate lines up between Jack and Linda. Oh, that's that one. And then Kate is last. So Kate is last here and here. So that's 2, also out of 6, which is 1/3. Oops, sorry about that. And then the last problem, we've got Micah rolls 2 number cubes. What's the probability that the sum of the 2 numbers will be less than 4? So here they use, notice they say, and it doesn't say, but I would use a table here. If you use a table, you can see that we've got 1 through 6 possibilities when you roll the first cube, and 1 through 6 possibility. And then here's all the outcomes. There's 36 of them. Here, order's not, wait a minute, let me think about this. Yeah, order's important because you got 2 different cubes. So order would be important here. And the sums that add up to something less than 4 would be these 3 right here. This adds up to 2, 3, and 3. All the rest of them add up to something greater than 3, which means they would not be less than 4. So when we look at this, we can see that there's 36 outcomes. And so that would be 3 out of 36, which would be 1/12. And that's the end of our video for today. You can rewind and as much as you need and take notes on your note papers. And then tomorrow we'll do some problems. Have a good day.